As Martin was saying, there's been some changes recently. When they invited me to speak here, I was working at a company called Case, which was a consultancy in New York, and now I work for a company called WeWork. And so this presentation's kind of an amalgamation of like stuff that we're doing at Case and then stuff that we're starting to do at WeWork now. This particular slide is a slide from Case. It's a slide that we'd start every presentation with, and it was a slide that was on our business cards, on our t-shirts, on pretty much everything that Case did. Dave Fano, who was one of the co-founders of Case, developed this kind of diagram to really, I think it was kind of a three-word manifesto for our company, buildings equals data. And what he meant by that is that buildings are these things that are producing data, and that data is this thing that's producing buildings now. And like any equation, understanding one side of the equation helps you understand the other side of the equation. So if you understand the building, you can understand the data better, and if you understand the data better, you can hopefully create a better building. As architects, we're really good at understanding buildings. We're trained at understanding the production of architecture. But it's only recently that we've had to grapple with this production of data and understand what data is. And for many architecture firms, this is a real struggle. I know everyone in this room is like incredibly adept at this, but when you go out and practice like we're doing at Case, we would go into these firms and kind of listen to the troubles that they were having adopting technology and offer them kind of strategic advice about how to go through that. Often they were really struggling with that. You can see that kind of reflected in the UK with the UK BIM mandate, which is like a governmental regulation kind of trying to force firms to adopt technology. And often these struggles aren't struggles with technology. All the firms that we spoke to have pretty much equal access to different technology. They all have skilled, motivated people inside these firms. Often the kind of thing that was holding a firm back was something to do with its organizational structure. So today I want to talk a bit about how models manifest in practice and how practice supports the practice of modeling. And I think in this I'll talk a lot about why Case shifted to WeWork and why WeWork is this kind of platform that's going to allow us to do better work at modeling. To start with, just to talk about data and to give like a sense of scale to data. If you were at an architecture firm producing, say, a Revit model, a 400 megabyte Revit model is a pretty large model. And if you were to, like, say, test your BIM manager out, you might make it to a gigabyte, and you might federate together a couple of models and get to, say, 10 gigabytes with some other data inside there. If you compare that to a company like, say, Facebook, Facebook processes 10 gigabytes of data every second. So when we're talking about data in the architecture industry and we're talking about data in, say, the technology industry or the startup industry in places like Silicon Valley, there's a different order of magnitude of data that they're talking about. But there's also a difference in type of the data that architecture firms are dealing with and that a company like Facebook is dealing with. When you look at the type of data that an architecture firm is dealing with, generally that data is really specific to one single project. So you'll know a whole lot about one project. You'll know all about the thermal conditions of that project, you'll know about the furniture inside that project, but you won't have so much of a sense of the other projects. Even within architecture firms that Case worked with, some of the best ones, they would struggle to understand their portfolio of buildings that they'd developed in the past. They might have an archive of buildings, but they'd find it hard to take lessons learned from the past buildings and apply them to the new buildings. If you compare that to a company like Facebook, you have this huge amount of data that pertains not just to an individual person, but to the huge population of people. And so it's quite different in its characteristics and types. It's interesting to look at how a company like Facebook positions itself. This is the first advertisement that Facebook made. And in it, you see Facebook comparing itself to kind of vernacular architecture. It's saying, in many ways in this advertisement, that these places or these things that we thought of as being architectural now belong to the digital world. And you see this kind of reimagining of the Maslow's hierarchy where architecture, which once was in the very base of the triangle, providing shelter to human beings. Maybe that's now replaced by access to data. You can also think about the upper levels of that triangle, things like self-esteem, belonging, that really, in some ways in the contemporary world, come from a connectivity with data or understanding data or in the digital world. I know that Uber is maybe not the favorite thing in Europe at the moment. There's been a lot of kind of strife about it, but in America, it's this thing that's really taken off. And in pretty much every city that you go to in America, the city is being changed by Uber. So this is an article from the New York Times about how LA is being changed by the introduction of Uber into the city. And what's really interesting about this is that LA, if you've ever been to LA, is this kind of city where cars aren't just like a mode of transport in LA, they're like a real status symbol, they're a real part of the identity of LA and Los Angeles. And so for years and years, people have been trying to change the way that the city functions. They've been trying to introduce different transportation options, and none of this has really taken hold. And what this article in the Times begins to explain is that the way that people are interacting with the city is changing because of Uber, that they're able to go out and they're able to party in different places because they're not as worried about driving home drunk and stuff. And this changes the dynamic of the city. And it's interesting to think here that for like decades, urban designers have been making these interventions into the city, and that what the city really required, perhaps, was not an intervention in the physical infrastructure, but an intervention in the digital infrastructure to enable these changes. So I now work for a company called WeWork, which is a company that people often compare to Uber or Airbnb. They'll call it, say, the Uber of office space. Essentially, WeWork is a place that anyone can come to and rent a desk on demand. So if you want to go to the London office for a day, you can show up there, pay $50, take a meeting room, or come into the lounge, or take an office. We also offer kind of more longer-term, month-by-month rental in our spaces. And I think what characterizes WeWork, rather than just being kind of company that provides space for people, it's really this, that we're providing incredibly high-end spaces, so all the spaces are really, really nicely designed. They have a lot of amenities in them that you wouldn't find in a typical office, so things like quiet rooms, you'll find hammocks, you'll find lounges, personal like phone booths for having a phone call in, private offices, meeting rooms, all these different types. And these are all different kind of categories of spaces that we've assembled together to make the experience in the office a better experience than just a typical kind of open plan ball pit of people. And we also have things like, in this photo, free beer on every floor and free coffee and all of this kind of going on. And the buildings are full of these really interesting entrepreneurs and people that are starting out and like taking on the world, really kind of hustling to create a better world through the companies that they're producing. So these are just like some shots, like media shots, I guess, of WeWork. But please go to a WeWork. When you go to a WeWork, you'll see that like these shots are very representative of what the building is like inside. And the other aspect of WeWork as a business that not many people know about is that we have an application. So the application's like this interesting mixture of LinkedIn and like a building automation system. So on one sense, you can connect with people and say, if you're a designer, you can ask, is there another designer in this building that could help me with this? Or maybe you want to ask someone for an interview or something like that. So we connect companies both in the physical world but also in the digital world like this. And then the other aspect of the app is that it allows for things like meeting room bookings, control of the space, laying complaints about the space. All of that kind of stuff happens within the app. Buying food happens within the app. And within the R&D department at the moment, we're looking at different ways that the app can activate the environment. So controlling lighting, controlling access through different doorways, stuff like that. The part of WeWork that often gets like the media excited is our growth rate at the moment. So you can see that in 2010 we opened basically 2 offices. By 2013, the number of offices that WeWork had grown to 9. And what you see here, this kind of upswing, where in 2014 we opened 24, is this just kind of exponential growth in WeWork. In 2015, I'm not sure if I can actually give you the number, but I can say that this month we've opened 9 new locations. So we're expanding at this rapid rate. We're expanding all over the world. We're growing really, really quickly. And as a company, we're worth or valued at the moment at $10 billion. So we have a lot of buildings that we're opening really quickly, and we have a lot of data that we're using to produce these buildings. So today I really want to discuss how it is that we're opening buildings as much as we are at the quality that we're opening them, and discuss how we're using data internally at WeWork to allow us to produce these buildings. I'll give kind of 4 examples of this. The examples that I give, they're not going to be the most sophisticated examples that you've ever seen of data use in architecture. They're, in many ways, these very pragmatic things, but I think they're very indicative of maybe some of the struggles that we're having in practice and some of the ways around this that a company like WeWork is able to give. So the first one is to do with laser scanning, and this is a video by ScanLab in the UK. They're not in any way affiliated with WeWork, but I just think it's a really beautiful video of laser scanning. But laser scanning is this technology that we've had in the industry for ages, right? I think Mark used laser scanning on Strada Familia something like 20 years ago. Yeah. So it's something that we've had for this really long time, and in recent years there's been all these like major developments in the cost of the technology, so it's coming down rapidly, and also the ease of use for the software analyzing and understanding all of this data. And the kind of interesting thing about laser scanning is that it's not really used that much in practice, that it's still not commonplace for a firm to come in and scan a building before they use it. Like some of the firms definitely at the high end are doing that, but you'll go into a lot of firms and they won't really even know what laser scanning is. And I'd argue here that the failure of laser scanning to take itself up in the industry isn't a failure necessarily of the technology, although the technology could always be better, but perhaps it's also something to do with the way that the organizations within the production of architecture are operating that leads to this reluctance to use the technology. This is a building that we scanned for WeWork. WeWork scans every building that it inhabits, and we tend to try and scan the buildings before we sign a lease on them. So really early on in the process, we're scanning buildings and analyzing them before we even own the space. And the reason for that is that we had a really bad project. We had a project where we didn't scan the building. It was a new project. The slab in the building was deviating a little bit. And when we manufacture a lot of the WeWork kind of off-site and ship it in and just assemble it inside the space. And when we went to assemble it, because of the way that the slab was moving, the partitions didn't fit into the spaces. Which was really costly for us because we had to go and recut everything, we had to delay the opening, and it was this really expensive kind of exercise for us. So now we scan every building because it's fairly cheap to do. And you can see in this building, which is an old timber building in Chicago, down in this corner you can see how it's sagging. You can also see in the staircase some deviation in the floor plate. It's not a big problem if you're aware of this beforehand, but it's a huge problem if this happens later on. So often what you'll see in the real estate industry is kind of a discount given to buildings like this because there's a certain amount of risk someone assumes when they take on a building like this with the unknowns inside the building. So by being able to scan this building and do it early on in the design process, we're able to eliminate much of that risk, and we're able to be much more competitive in the buildings or our prices for the buildings. And we're able to not just take new space, but also start to take some of these old and kind of interesting spaces and kind of rejuvenate parts of the city that might be forgotten about or looked over by developers who were preferring to go with the kind of safer option. So that's like a really simple example of how WeWork is using really off-the-shelf technology to help us as a business. This is the second example that I want to go through is how we're using data to produce kind of business intelligence for WeWork. So this is a tool that we have internally that has every building that WeWork's worked on. So this has both the buildings that we've opened and the buildings that we've proposed and the buildings that we're thinking about. And inside this tool, which is available to anyone in the office, you can go in and you can see all these buildings. You can see the opening schedule. You can see how much square footage we're opening. You can see occupancy rates. All of that kind of stuff is inside this tool. Again, it seems like something that would be really simple and straightforward, and in many ways it is. It's just a database connected to a web server. But if you go into an owner organization, typically they won't have this type of data. They'll have maybe a spreadsheet of their buildings. If you ask them a question, say like, how many floors are in this building in Park Avenue, they'll typically tell you something. They'll like call up someone at the building, like the security person, or they'll call up the building manager and ask them, because they don't even know kind of the size of the buildings necessarily that they have. So all this information that we have at WeWork, we're able to like look through it like this. And because we're modeling everything in BIM, we're able to drill into all the floor plans, drill into all the data inside all of the buildings. This is just one of the buildings, but to give an example of how we're using this in the R&D department at the moment, we're trying to improve the back of house spaces in WeWork. So we're able to take this collection of models, query what every back of house space looks like, and get the kind of dimensions for every space and its configuration and spatial relationship within the building, and then correlate that with a survey that we've given to people that manage those spaces about their kind of opinions on how well that space is laid out, and begin to identify then these correlations between spatial layout and perceived value of the different spaces. And of course, we can drill into kind of the level of the room or the level of furniture. Again, if you could imagine, we buy a huge amount of furniture. We need to understand where all this furniture is inside the different buildings. We need to understand where we're putting furniture and like where we need to store furniture and stuff like that. And so a lot of this work came out of work that Case was doing initially for MBBJ and later for SOM in analyzing their BIM models. So this is a tool that Case developed for SOM, and it's called the SOM BIM Dashboard. And what happens in this tool is essentially every model that SOM's ever produced is aggregated together and analyzed. And we're able to analyze these models for things like adherence to BIM standards. We can look at things like the size of the model, so tracking how the model progresses over time, which again seems like really simple, but if you imagine that you're a BIM manager at SOM, you're doing all these massive, interesting projects, you don't necessarily have time to go into every model. And so a tool like this gives these kind of high-level statistics about the quality of the models happening inside the firm. Ambitions for building analytics inside WeWork is to start to aggregate together all these different data sources. So we've been talking a lot in the last couple of days about the algorithms and the data associated with the design of architecture. But there's all this other kind of data that we want to have access to as people that are managing a company like WeWork. So data about real estate, data about construction, data about how the facilities and operations are moving, data about sales and marketing and occupancy rates and all that kind of stuff. We want to aggregate it all together and understand these relationships between, say, a real estate decision and how that comes to affect a facility's operation. So I'll dig into like one of those circles, which is the construction sequence. And this is a project that Case did for Stanhope in the UK, but it's kind of indicative of where we're thinking about this within WeWork as well. So this is Chiswick Park, which is a really large kind of development on the outskirts of London. And it's really interesting because kind of like WeWork, there's 12 buildings on this site. Every building's fairly identical, but a little bit different. And so what happened on this project is that they were able to construct each building, learn from what they did in the first construction, take those lessons and apply it to the second and third and fourth and fifth building. And so we're working on the 12th building, and for the 12th building, they really wanted to test out BIM as a way of managing the construction process here. So Case did what we typically do on a project like this, which is get all the trades to model every element inside the building, and we then take them together and we compare what one trade thought that they were doing to another trade, and we find the kind of discrepancies and the errors and the clashes between all these models. This is really standard stuff in the industry. What would typically happen, though, in the industry would be that you'd find all of these clashes, you'd maybe put them into an Excel spreadsheet, you maybe email them to people, but we were often finding that this process of discovering the clashes, that they would get lost somehow in the kind of human aspect of coming to resolve the clashes. So what we did at Case is we developed this system using Jira. Some of the software developers in the audience are probably very aware of Jira. It's this platform that allows the management of teams, and one of the features inside Jira is kind of bug tracking, so you can find a bug in a software and then track the resolution of the bug right through to the end. What we did inside Jira was we connected Jira to Revit, and then like things like Celebri and Tekla and Navis work. So we could identify an error inside a Revit model, upload it to Jira, view the error inside Jira, but also view the error in all these different software platforms. And so this is what a typical error looks like inside Jira. Again, it's just kind of a simple website. It has images of the error, all this kind of metadata about what kind of services the error involves, so things like ducts or slabs and stuff like that, who's assigned to deal with the error. And what you see down the bottom here is a start of a discussion about how to resolve that error. So typically these discussions would be left until we have a big meeting, but with an open platform like this, it allowed us to have these discussions before the meetings needed to take place and to resolve errors early. One of the advantages of using a platform like this is that we suddenly have all this data, not only about what things inside the building are causing these clashes, but we also have all this data about how these errors are being resolved. And so just, I guess kind of conscious of time, I'll focus on this graph here, which shows along the kind of x-axis here is time, and on the y-axis here is the number of errors, and the colors there correspond to different trades. And what you'll notice about this graph is that you see this big spike here, which is caused by the mechanical engineers, and then kind of other subcontractors or trades spiking later in the design process. And so what's really interesting about this spike by the mechanical engineers is that you can see that they've been onboarded into the process, and that almost immediately there's all of these clashes found between the mechanical engineers and the architects, and that it kind of spikes really high, and it takes a very long time for them to pull this back down to fix these errors. And then it spikes again, probably because after they've fixed the errors, Case has gone back and found more errors in the new work. And so we can look at that data and we can begin to ask questions of it. We can ask, is this error caused because that was around Christmas and then maybe they slacked off and they weren't working as much? Or I think the more likely kind of answer to this is that this team was brought into the process too late, that they should have been there earlier to work with the architect to resolve some of these things before they got into this phase of the project. So I think this is an interesting example because it shows the effect of maybe bringing a team in late to the process that should have been in there earlier, and it begins to suggest a way of doing another project that might help mitigate some of these problems later on in the design process. Again, we can track things like comments, and you can see in this graph things like periods where comments either dropped off and the team stopped working, or also kind of at the end here where everyone's in this mad rush to finish, so they're all suddenly communicating and getting shit done. And this final graph, it's one that I really like. It's, again, like a really simple graph. The size of the bubble, and yeah, the text is real small, I'm sorry for that, but the size of the bubble corresponds to the number of errors in that particular category. So this is the errors associated with pipes, this is the errors associated with ducts, this is the errors associated with slabs. And those are the kind of things that you would expect on a typical project to have kind of errors associated with them. They're always going to have errors with those kind of things, or clashes. You can see some interesting bubbles in here as well. Things like sanitary has a lot of clashes and errors, lifts has a lot of clashes and errors. So you can go back and interrogate this diagram and ask, was there something about the way that this building was designed that led to all of these clashes with the lift shaft? Was there something that the architect could have done earlier in the process? Was there something in the design that we could have changed earlier that could have helped mitigate some of these problems before they became issues later on in the construction sequence? The kind of final thing that I want to look at is how we're using data inside WeWork and initially at Case to kind of understand the users or the people that are using the building. So this was research that was inspired at Case initially by looking at the ways that buildings were producing data. So we had this situation where we knew that there were things like the lead dynamic plaque that was gathering data about energy use and the way that the building was being used and dynamically kind of evaluating the building's performance. We had things like Nest that were allowing people to control the temperature inside buildings and upload all this data into the internet and refine the kind of temperature inside the building. And at Case, we became interested in helping or getting ahead of this trend so that we could help our clients begin to use all of this kind of sensory data to understand their buildings and make their buildings better places. So we produced this iPhone app that tracks where people are inside space. So basically you turn on this app and it begins sending your location within the space into a server. And then we invited a PhD student at RMIT University, Marnie Williams, who's been doing all this like really great work with the Zigbee system to track and analyze people's locations in space. Some of you might have met her at some other conferences. She does, really great work. And working with Marnie and Andy Payne and myself, we began to analyze how people inside the Case office were utilizing space. So this is the day of one person who was training at Case. What's kind of interesting about this diagram, the line's a little bit faint, but you can kind of see where she was. She spent most of her day kind of working in this room, teaching people how to use Revit. But what's interesting about this diagram is that if you were to ask her what she did that day, she'd tell you that she was training all day. But when you actually look at how she spent her day, she spent kind of 6 hours training. She spent an hour at her computer answering emails and stuff. She attended a meeting over on this side of the office. And so there's a very rich picture that you get of how the office is actually being used in comparison to how someone perceives the space being used. We're able to make all these kind of diagrams, understanding and analyzing how the space is working out. So this is a diagram that shows time along on the x-axis and the number of people in the y-axis. And the color here corresponds to the number of people in each room. And what's interesting here is that you can begin to see the flow of people between different spaces. So these are people in the main working space, and you can see around lunchtime that they're leaving that space, the other kind of main working space. This is a space that's got presentations happening in it, and you can see a lunchtime presentation happening in this space, but then also how underutilized this space is during the rest of the day. Part of this research that really surprised me, and this really came a lot from the work that Marnie was doing, was how knowing someone's physical location inside a room also allows you to understand their relationship inside the organizational hierarchy. So rather than looking at the org chart of Case, you could begin to look at where people are spending time and who they're hanging out with, and begin to infer these relationships between all the people inside Case. And the other part of this research that was curious was some of the stuff shown in this diagram. In this diagram, the width of the arc corresponds to the size of the room, and the depth there corresponds to how often that space was inhabited. So you see things like the main work areas, they take up a lot of space inside the office and they're inhabited pretty constantly. But you see a couple of things in this diagram that really stood out to us and that kind of troubled us a little bit. Things like the kitchen, which was this area we'd spent a lot of time designing in the new Case office, was the space that really wasn't used a lot. So we had this kind of vision as designers that we'd design this kitchen and that everyone would kind of hang out there and have all these kind of coincidental meetings with each other, and we would drink there, and all these things would happen in the kitchen. You can actually see that it's the space that people spent the least amount of time. And the same with these single workrooms. We're actually worried when we designed the case office that we didn't have enough of these rooms, and we considered taking out the server room to make more of these rooms in the kind of planning stages. But what this data shows is that maybe either those rooms weren't well designed, or that we had too many of them. In any case, they weren't used as much as we had anticipated. Kind of, for me, one of the frustrations of this research is that we could get it to this stage. We could say that these rooms weren't really used, or that there was some kind of fundamental problem in the architecture, but we weren't ever going to redevelop the case office. No one was ever going to pay us to redesign the kitchen. So we got it to this stage where we could say that there was a problem, but we could never do anything about it. And I think one of the interesting things in being at WeWork and being at a company that's opening so many buildings that are so similar all at once is that we have this ability to affect change, that we can see things like that was happening in that diagram, and we can begin to change how the office is working. So this is a study that we've begun doing at WeWork. It's a really large study to kind of gather user metrics about how people are using spaces. This is just like a typical floor plan inside WeWork. You can see here a series of conference rooms, and then these are kind of single spaces for people to work in. And we're really interested in how the conference room is working as a topology within the larger office, and how to make those spaces even better for the people that are using them. So to do this research, it's really not very sophisticated in its data gathering methods. We just developed a kind of website where a researcher can go through and walk through the office at a regular interval, and count the number of people inside different rooms, and mark what kind of equipment is being used and what they're doing inside those rooms. And we begin to get from this all this data about both, like, we can correlate, we have all this data about where people are inside the building, how many people there are, and we also have all this booking data from the WeWork app about who's booked a room, how big the room is, which other kind of rooms they've booked on the floors before. And we can start looking and interrogating this data to make the design of the WeWork spaces better. So this is just like one example of the kind of insights that we're pulling out of this data. This is looking at the number of people in a 4-person meeting room. So as you'd expect, inside a 4-person meeting room, most of the time you kind of have 2 or 3 people hanging out there. Sometimes you'd get 4 people. On occasion, it would be someone would sneak another person into that room, and then occasionally the room's completely empty. But what's interesting is that when you compare this to a 6-person meeting room, the graph is actually pretty similar. The median size for a meeting in a 6-person room is 2 people, and the median size for a meeting in an 8-person meeting room inside WeWork is 2 people as well, which is curious because we charge people more to inhabit an 8-person room than a 4 or 6-person room. So there's something going on here. The designers, or you can think, as a designer, you're designing these meeting rooms like an 8-person meeting room and assuming that it's going to be full of 8 people all the time, but a lot of the time, an 8-person meeting room is actually a room for 2 or 3 people. Again, looking at things like correlations between the number of people in the room and the type of equipment that they're using. So as you'd expect, there's a fairly good kind of linear correlation here between the number of people and the equipment that they're using. If you have a bigger meeting, you're more likely to be using a whiteboard or a projector or both of them. And if you're there hanging out by yourself, you're not likely to be using the projector or drawing things on the whiteboard. What's interesting is when you take this into kind of nominal values, although these people, like the groups of 8, use the spaces a lot, they actually represent a very small number of the people using the spaces, and that the vast majority of the people using the spaces are maybe 2 or 3 people not using any equipment inside the spaces. So this is something that we're currently exploring at WeWork. We're looking at this data and we're thinking, how can we make the offices or the meeting rooms more conducive to these people that are maybe only 2 or 3 people? Maybe we can put in furniture that's more comfortable, that allows a conversation to take place without needing to put technology into the room. Maybe we can make these rooms kind of more acoustically tuned to that kind of meeting, all that kind of stuff we're now looking at and trying to think. We're never going to remove the 8-person meeting room. We're always going to have boardrooms and big rooms, but we're also thinking that there's this kind of group of people that's kind of underserved in WeWork at the moment who maybe we can serve better. And I'd argue that this is a piece of data that would be incredibly difficult to get if you were working inside an architecture firm. It would be incredibly difficult to anticipate before you built an office, to anticipate how many people were going to attend or enter into something like a meeting room. And that really what WeWork's able to do is to aggregate together all these kind of statistics and understand how, or predict kind of how the future of the building that they're producing or that we're producing is going to be used. So to kind of conclude this talk, I think we live in this like really interesting time in architecture. It's been kind of like, maybe for the last 10 years, certainly as Case has been talking about data, we've seen this growth in the use of data in architecture. It's become more and more a thing of how architects engage with and produce architecture. And I think in the last couple of days here at the Design Modelling Symposium, we've definitely seen lots of interesting new techniques, we've seen new technology, we've seen new ways of producing data. But I kind of fear that our discourse around the use of data in architecture is really kind of stuck in a 20th century understanding of architecture, that in many ways we're still focused on the ocular, we're more focused on producing renders than on producing buildings, we're more focused on things like algorithms instead of inhabitants. We're still discussing whether or not data produces a style, when perhaps we should be focusing on performance of buildings and the people that are using the buildings. So hopefully some of the examples that I've given today show some of the ways that I think data is going to come to affect architecture. I think much in the same way that we've seen with Uber and Facebook and the other companies from Silicon Valley, data is this thing that is global, that is massive, that is really consumer-facing or consumer-orientated, and that I think for firms to really make use of data and to use data as a way to produce better buildings, we also need to rethink the way that firms themselves are interacting and practicing the use or the creation of data. Thank you.